Here we have a word problem on derivative that is on rate of change. Okay, let's go with the information. A circle is increasing its area at a rate of 10 centimeters square per second. The rate of increase of radius when r equals to 5 centimeters. Okay, so we have at what rate the area of a circle is increasing, that is 10 centimeters square per second, and we have to find the rate of change of radius, that is at what rate the radius is increasing when the radius equals to 5 centimeter. Okay, here it is given how the area of the circle is getting changed, and when I look at the units over here, centimeter square per second, that means every second the area of the circle is increasing 10 centimeter square. That means the area of the circle is getting changed with respect to time. So how can we write this one using derivative? So that is dA over dt. So here this A refers to area of the circle and this T refers to time in seconds. So dA means what? Derivative of A. That means change in area with respect to change in time. So this is equal to 10. So the value we have over here. Okay, now we have written the rate of increasing of area of the circle as derivative dA over dt. Okay, now let me write the formula for area of a circle. That is A equals to, the formula for area of a circle is pi r square. So here A is area and this R is radius. Since we have dA over dt here, so I'm going to find derivative on both sides in this equation with respect to t. So when I find derivative of this e with respect to t, I'm getting dA over dt. Okay, now let's find the derivative of the stuff on the right side with respect to t. So here pi is a constant multiplied by the variable. So when I find derivative of a product where a constant is multiplied by the variable, the constant should be kept as it is and I have to find the derivative of the variable alone. If I find the derivative of this r square, I have to use the power rule of derivative. That is, I have to bring this exponent 2 in front of the variable r and subtract 1 from the exponent. So when I do so, 2 times r to the power 2 negative 1. So far I've done derivative only for the exponent 2 over here. By chain rule, I have to do derivative for the base r with respect to t. So what do I get? It's dr over dt. That is, when I find derivative of this base r with respect to t, that is dr over dt. Okay, here let's simplify. dA over dt equals to, we can write this 2 in front of this pi, then I'm getting 2 times pi times r to the power 2 negative 1 means that the exponent will become 1. But whenever the exponent is just 1, we don't have to mention 2 times pi times r times dr over dt. So here, what does this dr over dt refer to? So dr means change in radius with respect to change in time. So this is what we have to find, because the question is asking us to find the rate at which the radius is increasing when radius is equal to 5 centimeter. So the rate of change of radius we have to find. That is the rate at which the radius is increasing. That is, we have to find dr over dt in this one. So now to get the value of dr over dt, I have to plug in the value for dA over dt and also for this variable r. Already we know the value of dA over dt. That is the rate at which the area is increasing. That is 10. It's given in the question itself. So we can plug in 10 for this dA over dt. 2 times 5 times. They are asking us to find the rate at which the radius is increasing when r is equal to 5. So we can plug in 5 for this r. So 2 times 5 times 5. 2 times 5 times 5 times dr over dt. Okay, so we have 10 equals to, when I multiply 2 times 5 is just 10. So 10 times 5 times dr over dt. Now I have to divide both sides by 10 pi to solve for dr over dt. So let me divide both sides by 10 pi. When I divide both sides by 10 pi, this 10 pi will cancel out. 10 goes into 10 one times. Here 10 goes into 10 one times. I'm getting 1 over pi on the left side. On the right side, I'm getting dr over dt. Or it can also be written as dr over dt equals to 1 over pi. Okay, now I got the rate at which the radius is increasing when radius is equal to 5 centimeter. So here in numerator we have r. Already we know that the unit of radius is centimeter, so we can write centimeter. In denominator we have t, that is time. We have the unit of time in our problem is seconds, so over second. So the radius is increasing at a rate of 1 over pi centimeter per second. So I find this 1 over pi centimeter per second in option D. So the correct answer choice for this question is option D.